So the first day of a binomial distribution, we looked at the formula, which was n choose x and then p to the x and q to the n minus x. But that's for exactly that particular number. Like if you want 2 of them to work, if you want none of them to work, or 3 or 4, depending on how many you have. What we're going to look at today is 2 other ways of doing it. One is kind of very old school, which is using the table for it. But you can see the benefit of a table. For one, you don't have to make the whole distribution yourself. It's pretty much here for you, depending on different p-values, because that's really what we have across the top. These are all your p-values right here. So if the probability of success was 20%, then obviously you're going to kind of go over that way. Or if the probability of success was 65%, you're going to go here. But what would be a limitation of this table? You know, what about 22% or 37%? They're not on here. So this does have its limitations. But if you take a look, let's say, you know, we thought probability of success was 40%, and we knew that there were 4 possibilities. Well, basically all you have to do is look right here, and there's your probability distribution right there. For 0, for 1, for 2, for 3, for 4. They're all right there. You don't actually have to go and calculate them. Okay, so that's kind of nice that they're all right there. So if I wanted to know the probability of success is 40%, I know that there's 4 trials, and I wanted to know exactly 1 success, we know that there's a 34.6% chance, correct? But again, there are limitations. What if I wanted to know, in that case, less than 2? I would just add 1 and 0 together, correct? So it can save you some time, right? Okay, but we're also going to then look at the calculators, the graphing calculators, and they have even a greater way of saving you time, but you need to know what it's doing so that you can type in the correct information. Okay, so here's just a table. Obviously, they have lots of, I think I gave you a couple page one, didn't I? It goes through n of what? N being probably 20. Okay, and so you have a lot of options there, and so that's kind of how you use this table. We'll try a few examples here to see if we can kind of work our way through it. So here it says 50% of working adults spend less than 20 minutes commuting to their job. I personally spend less than 20 minutes commuting to my job. If you randomly select 6 working adults, what is the probability that exactly 3 of them spend less than 20 minutes commuting to work? I kind of like this example because it gives you a lot of numbers, correct? And you need to be able to decipher of the numbers which ones are important. So first of all, either they do spend or they don't, right? So it is binomial, right? And so why don't we figure out some of the important values? Like maybe let's figure out N, P, Q, and we could figure out the potential X values if you want. But we know which ones we really want to talk about. So what do we got? Do we know N? Is it 20? We got a 50? We got a 6? We got a 3? It's 6, exactly, because we're going to ask 6 people, so there's going to be 6 trials, correct? So that's what N stands for. Well, now P is probably not the 6 then, right? So we still go, we got a 50, we got a 20, we got a 3. These are all numbers in this problem. Of them, which one is P? 0.5 or 50%. Very good. So then Q is also 50%, right? And our X values are close. 0, 1, all the way to, whoops, I did too many. Oh, look out. I fixed it. Okay. And which one is of concern to us? Or are there many of them of concern to us? Only 3, right? Is the only one of concern to us. So the real X value that we really want to know about is just 3. All right. So then if we're going to use the table, this is exactly, so we could use the table. Okay. So I went to N being 6. So go to your table, go to N being 6. Is everything okay? Oh, yes, if you're doing the ellipsis, it is just 3 dots. Yeah. I don't know what it's called if you do 4. It's not an ellipsis anymore. Technically, it would be wrong, yeah. Okay. So how about we focus on this problem instead of how many dots we have? All right. Yes, if you're doing that for the x's, you can write 0 through 6 as long as you know exactly that it is just the digits or the whole numbers, right? All right, so here we go. N being 6. So I picked the kind of the rows that deal with N being 6. And then again, here is our 0 through 6 over here on the left side as our options, correct? And so now we got to go to the particular p-value, which apparently I didn't bring that with me. Apparently not. So which one over is 50%? So it'd be
the 0.016.
It's this one here, right? So this is the 50%er. Unfortunately, sorry about that. I should have brought the lead part with me, and I did not. So now I want to know exactly, because the p-values are up on the top, remember, right? And so I have to find the one that is exactly 3. So is it that one? 0.312, otherwise known as 31.2% chance. Do you agree with that? So 50% say it would. What is the probability? Exactly 3. Yeah, and do you notice that this one is extremely symmetric? 0.32, and then as you go out that way, 0.234. Why would this one be so symmetric? Yeah, it's 50-50 shot. It's going to be very symmetric. And do you agree that 3 should have been the greatest probability of all of them? Because 3 out of the 6 actually is 50%, so that should have been the greatest. Are you still once again surprised that it's so low? If it's the greatest, why is it only 30-some% chance? Exactly. We still have to spread 100% over all of these options. And keep in mind, this is only really 7 options. Imagine if there's 50 options, or 100, or 20. It's going to be spread out greatly. Okay? So here we go. Example 2. Blank percent of small U.S. businesses have a website. I left it blank because I figured that would change from year to year, and we'll kind of make up what we believe the number to be. If you randomly select 10 small businesses, what is the probability that exactly 4 of them have a website? So I would even say over the last 3 years, this number has probably changed greatly. Do you think it's 90%? Well, we can't really use 87% and use the table. 85%? Should we go with 85? Sound good? So we're going to go with 85. That is our thought here. So 85% of all small businesses have a website. So we're selecting 10. So either they do or they don't, right? And so let's kind of talk about our important bits of information. Do you believe it's binomial then? Yeah, they either do or they don't, and each one has the same percent chance of 85%. So n is, we got lots of numbers in here. N is what for this particular problem? 10. Yep. And now that we're using the table, we know P is probably really all we need to know. You know, if we're going to go to the formula, then we also need Q. But if we're just going to use P, we're going to go based on what you said, 0.85, right? Q would be, if we needed it, what? 0.15. And our possible X values are 0, 1, all the way to 10. Okay. Hopefully this time I brought the header. Oh, I did this time. There we go. It's a lot easier. And so I went to n being 10. And again, you notice over on the side, we do have 0 through 10 right over here. Okay, and you said 85%. So this is the up to 3 decimal places. What do you notice about some of our options here? 0. So does that mean 0% completely, or that just means out to 3 decimal places? Do you believe that some of them are a very low probability? Yeah, we said 85%, right? And so we shouldn't be surprised that 0, 1, 2, what, all the way to 3 are to 3 decimal places, nothing. And so which one are we exactly for? Right? Exactly 4 is 0.001, otherwise known as 0.1% chance. Do you believe that? If it wasn't 85, if it actually was 85%, we went out there and asked 10 small businesses, exactly 4 of them saying yes is only 0.1%. Do you believe that? Yeah. So which one should probably be, which ones should be your highest? 8, 9, somewhere in there, right? Because it's out of 10, right? So we're not going to have 8.5 people say yes, right? So if you look at 8 and 9 again, you notice that they are some of your higher probabilities. Okay. Questions on using the table? Pretty nice, but again, limited to p-values. Okay. And you probably would have really liked this one in other days that you had to make the probability distributions because it would have been done for you. It would have been right there. All right, so here we go. We're going to use the TI-83s, or whichever one you happen to have for a graphing calculator. The results of a recent survey indicated that 58% of American households own a gas grill. So right away we know the table's not going to be very helpful on this one because we're looking at 58%, right? If you randomly select 100 households, I don't think we want to make this probability distribution on our own. There's 100 possibilities, I don't think. And plus there's 100. Did I even give you the table that far? I did not. I only gave it to you to 20. What's the probability that exactly 65 of the households own a gas grill? Could we use the formula? We could, right? But let's see if we can actually use the calculator as well, and then I'll show you where the calculator can probably be used a little bit better. So let's figure out some of our information. N is 100. P, 0.58. That's all you need. You need P, you need N, and then you need the X value that is of concern. So which X value is of concern? 65, correct? It is 0 all the way to 100, correct? But this is the one of interest. Because N, P, and X are going to be the three things that your calculator is going to ask you for when you go to where we're going to go. Is everybody ready? No, we are not going to Disneyland. So, but we are not even going to go to stat. This is a binomial distribution. So we're going to go to the one that would quite possibly be distribution, which is above the variable or varies button. So second, right there, it's right above that button there that's still highlighted in red. Now you see normal PDF, normal CDF, inverse of a normal, inverse T, T, chi-squared. You see lots of things, but actually to get to binomial, it's quicker just to go up and go around. So there's binomial. There's two of them though, the big letter A and the big letter B. There's binomial PDF and binomial CDF. PDF is a probability distribution function. Okay. CDF is a cumulative distribution function. We're going to use the cumulative one very soon. All I did is I went up. Is everybody at that page? Because really this is probably where you started. So you can either scroll all the way down or you can just go up. Okay. Or you could just hit A. Whoop, I think I hit it too many times. So just find yours. I may have different ones. But find your binomial probability distribution function. If I were you, I would write down these directions on my notes somewhere. So once you get there, hit enter. It's a probability distribution function, and yours is once again going to look different. And I will write it up on the board once we get done. So yours is probably going to look just binom PDF is all you're going to have on yours, correct? Does it give you a parenthesis? It does? Okay. So the first thing that you're going to put down is N, which is the number of trials. And so what is N for you? 100. Okay? Because yours probably looks more like... Yours probably looks like that, correct? So then you have to put in X, which is the number of trials. Do you notice that's the very first thing it's asking me for as well? Okay. Now you're going to put P, which was what for our problem? 0.58. You got to put the comma, though. Is everybody clear with where the comma is? Because do you think the calculator is smart enough to figure out Q if I give it P? Probably, right? Probably can handle that. And then now the X value that is of concern. So 65. Please realize if you switch the first and last number, it's going to get very confused because you're going to tell it has 65 trials and you're concerned about the 100th one. See how it might be very confusing for the calculator at that point. Okay. Okay. So let me catch up right now. Does everybody have that one? So 100 trials. P is 0.58. X value that is of concern. So mine comes up the same way. It's just a graphical interface. Now I know that. There we go. So that's what yours should look like, correct? But yours should probably off to the other side, right? So this, what it did is it pasted it to my main screen or the calculation screen. So just hit enter. Oh, I think I hit that button a few too many times. There we go. Whoa, I did it twice. It's a little slow today. It's all right. So we got 0.0299. Okay. Or yeah, approximately 3%. Right? If you were to round it. So that's just the probability distribution function, so it's just going to give you one value. That's all it's going to give you just for that value you tell it, which in this case was 65, correct? Okay. So why don't you go ahead and try the next one on your own? It says the results. So again, this is about 3%. So the next one says the results of a survey said that 71% of Americans use more than one topping on their hot dog. If you randomly select 250 Americans, so obviously not going to use the table on this one, what is the probability that exactly 178 of them will use more than one topping? So binomial PDF. Okay, what order should I put things? 250 I was told to put first. And 0.71, and again, the formula still works on these, okay, but that one might save some time and hopefully $250, 0.71, and 178. .055. So if you move it over twice, about 5.6%. Do you believe that? Why is it so small? Because isn't 178 over 250 pretty close to that range? I got to spread it out over 250 possibilities. Exactly. So that's why there's a problem there. Okay. Okay. All right, so next one. A survey indicates that 41% of American women consider reading their favorite leisure time activity. You randomly select 4 women and ask them if reading is their favorite leisure time activity. Determine the probability that exactly 2 of them respond yes. So, well, we can't quite use the table because it is 41%, which we don't have. Otherwise, we could have. Exactly, we could have gone to that table. Probably would have been quicker. But we can actually use binomial PDF, or you could just put the formula together, remember. Okay. And so what's n though? 4, okay. And 0.41, and y2. Yeah, exactly 2. Yep, so 2. Or again, you could do 4 choose 2, 0.41 to the second, and 0.59 to the second. Right? That would work as well. It would give you the same answer. And once somebody gets that, please let me know. 0.351 approximately, right? So approximately 0.351, otherwise known as about 35.1% chance. So now this one gets big again. This probability got pretty big, but again, 2 out of 4 is kind of close to the 41%. This time I don't have 250 options or 251 options to spread it over. I just have basically the 5 options, right? 0, 1, 2, 3, 4. And so that's why that probability is much higher. Okay? Whoa, how about this one? At least 2 of them, or fewer than 2 of them. I'm gonna help you out on this one, because the calculator can speed this process up as well, as long as you know how to use the calculator. I look at B and C as being complements of each other. One is at least 2 of them, so that means 2 or more, and C says fewer than 2, so that means 1 or none, right? So really what I want to know here is that 0 or 1, correct? And here I want 2, 3, and 4. Agreed? Did you notice that there was binomial PDF, but there was also binomial CDF? That'll accumulate it for you up to whatever point you tell it to stop. So now, I can't really tell it due to 2 to 4, though. I can't really tell it that. Because whatever number you put last, it's going to take from 0 all the way up to whatever number you put in that X spot. This spot right here, if you do CDF. So of these 2 problems, which one should we probably do first? Which one's the calculator going to be more helpful on? Actually C, Because what we're going to do is we're going to put binomial CDF. We're going to put 4. We're going to put 0.41. Now, how far do I actually want it to add up? I want it to do 0, and I want it to do 1. Do I want it to do 2? No. So what should I put in here if I want? I tell it when to stop. 1. Okay. That will put basically 0 and 1 together for me. Now, let's face it. In this one, could we have done them individually, and it wouldn't have been that bad, and just add them together, right? But can you imagine in that other one with 250? You're not going to want to do that. You're just going to want to add it up as far as you need to. And what this will do is it will tell me put 0 and 1 together. It'll add up from 0 all the way there. So let's see what that looks like. So where was that again? Yeah, above that. So you got to go second in there. Hopefully mine works. Whoa. Hopefully mine works a little bit better. It's not really here, so I'm just going to go up and find binomial CDF. Right? That means cumulative. You might want to give yourself a note. That's what the C stands for. Again, yours is going to look a little different, but I wrote it down for you, right? So number of trials, I believe, was 4. P-value 0.41. The X value that we are concerned with is up to 1. And again, this is just going to paste it so it looks just like yours. So it should look something like that when you get done. Notice again, you can see that it is the CDF, right? And what's it really doing? It's going to add 0 and 1 together. And so that is the answer for which problem? That's C. Okay. So it's about 0.458, I guess if we round to 45.8, right? Everybody ready with that? So 45.8 is what we're going to say, or 0.458. This one's about 0.458. So to get this, it's really 1 minus that binomial, right? Now, of course, you could type all that in, or we could just do the math on our own, right? Because what if you weren't asked to do this one? Can you just do that one and then subtract? Yeah, that's fine, right? And so basically it's just 1 minus this, which ends up being approximately 0.542, right? Here's some questions on how to use that. So you can see how that could be very advantageous. Okay. But you still need to know how to use it. Because what a lot of people do on C is they go all the way to 2. Okay, because they fail to read the words properly. Okay. Okay. So population parameters of a binomial distribution. The mean is mu, and all you have to do is take n times p. Because it's the probability of success times how many trials you have. So shouldn't that be how many are successful? If it's 50-50 shot and you had 10 trials, the mean better be 5. Right? So you would just take n, which is 10, times the probability, which is 0.5, and you multiply them together, and there you go, you got 5. Well, that even makes sense. Variance, which is sigma squared. You take n times p times q. Okay. But this only works if it's binomial. Just take n times p times q. For the standard deviation, then you take the square root of that. Yep. Just like in everything else. So here we go in Pittsburgh. 57% of the days in a year are cloudy. Could have something to do with all the industry. Determine the mean, variance, and standard deviation for the number of cloudy days during the month of June. What can you conclude? All right. Well, we got mean, variance, so we need n. Based on these formulas, we need p, and we need, whoa, that was not going to be a good one. There we go, q. All right, so now, of course, the statistics is not the hardest part of this problem. Everyone going to their knuckles to figure out how many are in June. Okay. It's 30. The way I remember it is that July and August are the only two back-to-back, because Julius Caesar did not want Augustus to have more days in his month than he did. And so he added one to him so they were the same, 31. And so June is less. Okay. July, Julius Caesar. Yeah. Okay. And P. .57. Be careful, I might be tricky sometime and say 57% days are sunny, and then down below be cloudy. All right, be careful. All right, and then Q is And so now to find the mean, if we know 57% of the days are supposed to be cloudy, wouldn't I just take it times how many days I'm looking at? And that should be how many days are cloudy, you know, on average, right? I mean, that makes sense. Okay, so mu. You just take n times p. Again, it makes sense. So there's 30 days times the probability of 0.57. So approximately about how many would I expect? About 17.1. Okay. Well, part of that day is cloudy. Yeah, partly cloudy. All right, variance. Sigma squared. Well, basically take the 17.1 I already know from first one, which is n times p, right? And take it times q. That's what I would do. And q was 0.43. So how many days in that month, how far would it vary, right? That's what we're talking about there. And it's about 7.35. And unfortunately, that's number of days squared, right? That's not even the same units we started with. So we go for standard deviation. And how do we do that? We take the square root of that. So we would expect it to vary from 17.1 by about 2.71 days, correct? So again, about 17.1, but give or take about 3 days would give me a good percentage of the possibilities, right? That's what you can conclude. Questions? So you've got that table, but it's limited. You got the calculator, which really is only limited by you and your understanding of it. Okay, because it can do a lot of these problems, especially the at least and fewer and all of those, as long as you use the calculator properly.